All right, welcome back for example 2. Talking about dilations, a dilation can enlarge or reduce a figure. The scale factor describes how much a figure is enlarged or reduced, so that's kind of important. It represents the ratio of a length on the image to the corresponding length on the original figure. When a dilation in the coordinate plane has the origin as the center of dilation, you can find points on the image by multiplying the x and y coordinate of the figure by the scale factor. For example, if the scale factor is 3, and this is our original point, xy, the image, you take this x and you multiply it by 3, and then you take this y and you multiply by 3 for whenever the scale factor is 3. You multiply each of the x and the y by 3. Boom. Okay, let's go ahead and look at example 2. And we're going to use the origin as the center of dilation. So we're going to dilate this figure by a scale factor of 1/2. So what we're going to do is we're going to take each vertice. So let's start with A. Okay. A is -6, 4. And when we have a scale factor, what we're doing is we're taking our points, which is x and y, and we are dilating it by a scale factor of 1/2. So whatever the x is, it's going to get 1/2. We're going to multiply that by 1/2. And then whatever the y coordinate is, we're also going to multiply that is, and that represents a dilation of scale factor 1/2. So, let's write down A. So then what we're going to do is we're going to move that to A prime, and we're going to go -6 times 1/2, and then 4 times 1/2. And that is going to equal, right? I'm multiplying fractions. I look to cross cancel. 2 goes into both. 2 goes into 2 one time. 2 goes into 6 3 times. So that when I multiply across, it ends up being, A prime ends up being -3. And make that 4 over 1. We're going to do the cross canceling here. 2 goes into 2 and 4. 2 goes into 2 one time. 2 goes into 4 2 times. We multiply across and we get 2. And so there is our new point, A prime, after dilation of scale factor 1/2. So 3, -2. So that would be -3 up 2. This is A prime. Okay, let's do B. B is the point 0 and up 4. So we're going to apply that scale factor, which is going to give us B prime of 1/2 times 0. And then 1/2 times 4, and we know 1/2 times 0 is just 0. And 1/2 times 4, half of 4 is 2. So that is B prime, 0, 2. Okay, and then we're going to go to C. C is pretty easy because C is just 0, 0. So when we go to C prime, and we multiply 1/2 times 0, and 1/2 times 0, I mean anything times 0, is just going to be 0. So our C prime is still the same. But what about D? D is -6, 0. So D prime, we take each one of these, and the scale factor is 1/2. And we end up with 1/2 of 6. Half of 6 would be -3. And 1/2 times 0 is just 0. So D prime ends up being -3, 0. And here is our figure. This is a dilation. It is 1/2 as big as the original. I'm going to just use my green highlighter to accentuate this. I just feel like highlighters do such a wonderful job of accentuating. So this is 1/2 as big. It has a scale factor as 1/2 as the coordinates here. So that is a dilation with a scale factor 1/2. All right, so let's look at a different example, example B. Okay, we have this lovely triangle, and it says dilate a figure by a scale factor of 3. Okay, so if we do that, we start with the points x, y, and then they dilate 3 times, which means we times 3 times the x part, and we multiply 3 by the y part. So let's start with A. A is 1, 1. So we're going to apply this dilation and get A prime, and so basically 3 times 1, and then 3 times the y, which is 1, and we end up with A prime equaling 3, 3. So 3, 3, A prime would be right here. Okay, then let's go to B. B is 3, 1. And then we're going to do the dilation, which is going to give us B prime, which is going to be 3 times the x, which is 3. And then 3 times the y part, which is 1. And we end up with B prime, which is 3 times 3 is 9. And 3 times 1 is 3. So 9, 3, 1, 2, 3. And that is going to be our B prime. And then finally C. C is 3, 3. And we're going to get that dilation, scale factor 3. So 3 times 3, and then 3 times 3. That gives us C prime, which 3 times 3 is 9, 9. So 9, 9 would be right here. This would be C prime, and then we're just going to connect those dots. And this right here is a figure that is 3 times as big as this original figure. And I'm going to use my lovely green highlighter because I just feel like it does such a wonderful job of accentuating. 3 times as big. There you go. Boom. Okay. Now, ladies and gentlemen, I feel like it is your turn to try C and D. So here is my friend, the pause dragon. Remind you to pause your device. Go ahead and work out C and D. When you get done, press play and we'll go over your problem together. All right, see you in a bit. Okay, let's see how you did C. We have a lovely trapezoid, and we're going to dilate it by a scale factor of 2. That means we're going to start by each point, and then each of these is going to get dilated by a scale factor of 2, the x-coordinate and the y-coordinate. So let's start with A. A is negative 2, 2. And to get to A prime, we're going to take each one of these coordinates and multiply them by 2. And we end up with negative 4, 4. Okay, let's look at B. Oh, I should probably pull out that negative 4, and then it's a positive 4, right? Negative 4, positive 4, 1, 2, 3, 4. Right here. This is A prime. Okay, B is 2, 2. And we are going to apply that dilation to B prime. 2 times 2, 2 times 2. That ends up being 2 times 2 is 4, 4. So 4, 4 is right here. That is B prime. Let's go to C. C is 2, negative 1. And we're going to apply that dilation to C prime. 2 times 2 and 2 times negative 1 gives us C prime. 2 times 2 is 4. 2 times negative 1 is negative 2. So we have C prime, which is 4, negative 2, right here. C prime. Then lastly, there's D. D is negative 1, negative 1. And we're going to go to D prime. We're going to multiply each of the x and the y by 2, the scale factor. and we get d prime, which ends up being 2 times negative 1 is negative 2. 2 times negative 1 is negative 2. Negative 2 is right here. This is d prime. So then we're just going to go ahead and make our figure that is 2 times as big. And there we have our new trapezoid right there. A prime, B prime, C prime, D prime. If you got that right, great job. Make sure you show your work just like I have shown here. Okay, let's move on to the next one. We're going to dilate a figure by the scale factor of 1/2. So that means we're starting with a point x, y, and the x is getting multiplied by 1/2, and the y part is getting multiplied by 1/2 as well. So let's start with A. A is negative 6, negative 2. And to get A prime, we are going to multiply each one of those by 1/2. Okay, so when we do that, 1/2 of 6 is negative 3. Half of 6 is negative 3, and 1/2 of 2, or negative 2, would be negative 1. So that's our A prime, negative 3, negative 1. A prime. Okay, let's go on to B. B is negative 2, negative 2. And our scale factor is 1/2, so 1/2 times negative 2, 1/2 times negative 2. That gives us for B prime, 1/2 of negative 2 would be negative 1. So we have negative 1, negative 1. That is our B prime. And then let's go to C. C is negative 2, negative 6. And we are going to go ahead and put that scale factor of 1/2. C prime is 1/2 of 2 is negative 1. And 1/2 of negative 6 would be negative 3. So negative 1, negative 3 right there. And then let's go to D. D is negative 6, negative 6. D prime would be 1/2 of negative 6, and then 1/2 of negative 6. 1/2 of negative 6 would be negative 3, and 1/2 of negative 6 would be negative 3. And that is our D prime, negative 3, negative 3. And we make our little square there, which is 1/2 the size of this one. So if you did that right, wonderful job. And I will see you back for example. That's it for this lesson. So I will see you for the next chapter. All right, bye.